Hello everyone, welcome to Royal Palace online classes. Today I am going to discuss about vectors. So last two chapters I have completed, physical world as well as units and dimensions. Now we are entering into motion in a straight line. Before going to that, before entering mechanics, usually I will start with vectors, which are the basic concept in mechanics, which is a basic concept, because from here onwards you will learn many physical quantities like distance, displacement, velocity, speed, acceleration, everything you will learn. In that physical quantities you have to distinguish whether it is a vector or a scalar, whether that physical quantity has direction or not, that you have to find. So based on that I took vectors before motion in a straight line. So it is not a separate topic, you can find as a separate topic in a textbook. You can find this topic in a motion in a plane. If you open your NCERT, it is given in motion in a plane. So what is a vector? So physics consists of physical quantities. Physical quantities are there. These physical quantities are divided into two types. One is scalar, other one is vector. Some people will get doubt what is a physical quantity. Physical quantity means what we are studying in physics, like distance, displacement, velocity, speed, all these are comes under different types of physical quantities. Suppose we are learning about distance, it will have one definition. It will have one definition. We know in our bridge course also I explained distance and displacement. It will have one definition, it will have one unit, but this distance should come either under scalar or either under vector. It should be either scalar or vector. So how can you distinguish scalar and vector? It is very simple. The physical quantity which has magnitude and direction and which obeys vector's laws of addition is called a vector. So for time being you will learn vector means it should have magnitude and direction. But all the physical quantities which have magnitude and directions are not vectors, that we will explain later. But for time being you just understand vector means it is having magnitude as well as direction. So what is the meaning of that? Magnitude means what, direction means what? So let us take this distance only. You know very well, distance is measured in meters or kilometers. I will write this as 10 meters. 10 meters. See, this 10 is called magnitude. Suppose you are buying 2 kg of rice, 2 kg is magnitude, means it is having some value. So 10 meters, just I mentioned it as 10 meters only. If I tell this as 10 meters towards north, 10 meters towards north, then this is called as displacement, which is a vector. That means a physical quantity with its direction, we can call it as a vector. Distance with direction is nothing but displacement. Distance is a scalar, displacement is a vector. If you go back to our videos and see bridge course, there also I explained differences between distance and displacement. I told that distance is a scalar, displacement is a vector. Then you have to understand what is a scalar or what is a vector. So what is the difference is the physical quantity which has only magnitude. Scalars has only magnitude, it will have only magnitude. Only magnitude is scalars. The physical quantities which have both magnitude and direction is called vector. It has both magnitude and direction. both magnitude and direction. Direction, both magnitude and direction. And strictly speaking, exactly if you want to write the definition of vector, any definition in physics should have complete meaning. You should include the exceptions also. There are some physical quantities which have both magnitude as well as direction, but they are not considered as vectors. So for that reason, we can extend this definition by saying that vector is a physical quantity which has both magnitude and direction and obeys vector's laws of addition and obeys vector laws of addition. Vector law of addition, vector's laws of addition. So this is what the introduction about scalar and vectors. So what you have to remember is any physical quantity from now onwards, taken from first PUC to second PUC until you write your competitive exams, whatever physical quantity you are learning, that it should be either scalar, it should be either vector. That means that physical quantity should have magnitude as well as direction, or it may have only magnitude. This is the definition of vectors. Now, in this chapter, what we are going to learn is we are going to learn how to add two vectors, addition of vectors. Addition of vectors. Next we will study subtraction of vectors. Next we will study multiplication of vectors. See, you can get a doubt. Addition means we already know from 10th class, from our childhood onwards we are adding. 2 plus 3 is equal to 5. Subtraction also we know 3 minus 2 is equal to 1. Then why we are learning it specially in case of vectors? Vectors addition is different from normal addition, what we are doing in mathematics. See, for this we can take one example. There is a block of 10 kg. Person A is applying a force of 5 Newton towards this direction. Person B, this is person A, the name of the person is A, is applying force like this. Here another person, the name of the person I can take it as B, is applying force, same force is applied. Then it is common observation, because from our observation in nature only we can understand physics very clearly. It is common observation whether the body will move, it will not move, it will be at rest. But what are the forces acting on that body? 5 Newton and 5 Newton. So 5 plus 5 should be 10, should be equal to 10. According to Newton, body should move. Every body continues to be in state of rest until and unless you apply an external force. This you have seen in your previous classes. Body should move, but body is not moving. That means here 5 plus 5 has become 0. 5 plus 5 has become 0 here. Next time what you will do? Next time, person A will apply force like this. Person B also will apply force like this. Both are applying 5 Newton. Then body moves. In this case, 5 plus 5 is equal to 10. That means when you are adding vectors, you have to consider its direction. We can't add directly. If it is scalar, you can add directly. Scalar addition we can't follow for vectors. So for that reason, we have to study some special rules and regulations to add vectors, some special rules to subtract vectors, some special rules are there to multiply vectors. So this is the difference. So before going to that, we can have a clear look how a vector is represented and what are the types of vectors. The vector is represented as, suppose if A is a vector, on the top of the vector you have to give one arrow mark like this. This is called as A bar. We pronounce it as A bar. If it is B is a vector, you want to represent it as a vector. By seeing it, you have to understand that it is a vector. You have to give one symbol here. This is the symbol B bar. Suppose if you want to draw it on paper, A bar. Suppose A bar you want to draw. 5 meters is A bar. Then how to represent it? It is represented with a line segment with a arrow head, where length of the line segment will give the magnitude of the vector. Length of the line segment will give the magnitude of the vector, whereas arrow mark indicates the direction of the vector. This is the direction of the vector. Okay, this is the condition. And what may be the types of vectors? What are the types of vectors? Types of vectors are, you can learn unit vector. Unit vector means a vector whose magnitude is unity. The magnitude A bar can be said to be a unit vector. The magnitude of vector is 1. Next, null vector. Just like in your mathematics, null vector, null matrix. Null vector, what you will get? A vector whose magnitude is 0 is called null vector. Next, position vector. A position vector, just like in coordinate geometry, position vector is a vector which is represented with coordinate axis. Suppose there is a vector, let us assume a monkey walks 4 meters, afterwards take a left turn, afterwards it climbed a pole. Let us take a monkey, start walking 4 meters, it walked, another 4 meters it has taken left turn, there was a pole, it has climbed up that pole, now it is at the top. Now how can you represent its position from the starting point? Starting point, if you take 0, 0, 0, it has completed 4 meters along y axis, 4 meters along x axis and another 4 meters along z axis. So that position we will write it as 4, 4, 4. Suppose a vector is present in xy plane. A person walks from origin, and reaches here. How can you represent its coordinates? We will see its distance from x axis, that will take it as y coordinate. Distance from y axis, we will take it as x coordinate. Let assume it is 2, 3. Its position is 2, 3. That is called position vector. Unit vector towards x axis, this is very important in vectors. Unit vector along x axis is represented as unit vector along x axis is represented as I cap. Unit vector along y axis is represented as j cap. This we pronounce it as cap. Cap indicates unit vector. This is the representation of unit vector. This is the representation of vector. Suppose if A is a unit vector, I will write this like this, A cap. Okay. Next, along z axis we will take it as k cap. Okay. This is the condition. Suppose if I write a unit vector, a position vector A bar is equal to 2i plus 3j plus 4k means 2i plus 3j plus 4k, 2i cap 3j cap plus 4k cap. So, what is its meaning? The length of that vector along x axis is 2, length of that vector along y axis is 3, length of that vector along z axis is 4. In our previous example, monkey walks 4 meters along y, means I have to write it as 4j. It has walked 4 meters along x, I have to write it as 4i. Afterwards, it climbed up a pole like this, it is climbing the pole, means in which direction it is travelling? Along z axis. So, this I can write it as 4k. So, this is the displacement vector of monkey, I will write it as m bar in our example. Example is a monkey walks 4 meters along y axis and takes left turn along x axis, again it climbs a pole. So, left turn means sometimes you can take this as minus I also, because it is going towards negative x-axis. That is not the concern. The concept here is how to represent a position vector. This is the condition. It is similar to your coordinate geometry. X coordinate will write it as I. In this case, if you are representing a vector a bar here, this a bar can be written as 2i plus 3j. So, any position we are representing its position. What is its position? 2 along x, 3 along y. Okay. This is the condition. Suppose if a person walks here, from here to here, and like this, is walking like this. He walked 2 along x, 3 along y. What is distance from the what is the position from the starting point? Means 2i plus 3j. This is about position vector. Next, like vectors. Like vectors are the type of vectors which are having same direction, which are moving in same direction. Next, equal vectors. Equal vectors are whose magnitude and directions are equal, same. Okay. Collinear vectors, these terms you can understand. Collinear means which are on the same line. Co-initial vectors, which are having same initial point. Okay. This is about types of vectors. Okay. For null vector, magnitude is 0, direction is undefined. Okay. That you have to remember, direction is undefined. So, let us see how to add two vectors. How to add two vectors. Okay, now let us see how to add two vectors. How to add two vectors. Now see the magic here, how vectors will behave. In mathematics, in a scalar addition, it is very simple. Always, so let us take two numbers. I want to add two numbers. Now I am discussing addition of vectors. First we will see the definition, then afterwards there is one law, how to add. Two laws are there that we can discuss. Addition. How to add two vectors? Suppose I add two numbers. One is a is equal to 3, b is equal to 2. Two numbers are there. I want to add this. So, in generally what we can do, a plus b is equal to 5. Okay, a plus b, 3 plus 2 is equal to 5. So, that already I shown here. In case of vectors, it is not always equal. 5 plus 5 is equal to 10. Again same 5 plus 5 I got 0. What is the mean? I am adding only. But when two persons are pulling a body in different direction, body is not moving. Not moving means according to Newton force 0. but two fellows are applying force here. A is applying this side, B is applying this side, but body is at rest. So according to Newton, if body is at rest, force should be 0, but forces are applied, but that two forces are cancelled each other, they counteracted each other. The force applied by A is nullified by B by applying in opposite direction. If a person is moving towards you, you apply force, person will stop. Even though he is applying force, we can also, if you apply opposite force, it will stop. So similarly, 3 plus 2 is equal to 5 is not always valid. So then how to add, suppose if these two are vectors, how to add? So the first definition what they have given in NCERT is, if you are doing an operation A bar plus B bar, first to draw A bar. So that the length of the line segment represents the magnitude. Next, join the initial point of B. This is A bar. A bar is completed. I have drawn this over. Next, join the initial point of B with final point of A. Join the initial point of B. Join the initial point of B with final point of A. Next, initial point of B with final point of A and draw B. Okay, draw B. This is the angle between A and B. Okay, this is the angle between A and B. Now, angle between A and B. Now join initial point of A to final point of B, that will represent A bar plus B bar. When two vectors are acting in same direction, we got maximum 10 newtons. When two vectors are acting in opposite direction, we got 0. That means angle matters here. So angle is important. So if you know angle between A and B, you take A bar, first to draw A bar, next to draw B bar, such that B bar should be oriented in the angle between A and B, and you join initial point of B should start from A. Initial point of B should start from A. Then after drawing, join the initial point of A to final point of B. Understand very carefully. First draw A, next draw B, such that you should start B from where you ended A. Then afterwards, after drawing two vectors, join initial point of A to final point of B. This is going to give the resultant value of A bar plus B bar. So this is the definition how to add. Okay, this is how you have to add the vectors. For that, we can derive one formula. For this, we can derive one formula also. Because every time we can't draw, suppose vector is 1000 meters, you can't draw that 1000 meters on your book. So for that reason, there is one formula. For that you have to learn one law which is known as Parallelogram Law of Vectors, which is very famous question for your PUC. Parallelogram Law of Vectors. Parallelogram Law of Vectors. Parallelogram Law of Vectors. So what is this Parallelogram Law of Vectors is, if two co-initial vectors, if you speak strictly, two co-initial vectors represent two sides of a parallelogram. Two co-initial vectors represent two sides of a parallelogram like this. Complete the parallelogram. This is the parallelogram. Okay, this is the parallelogram. two vectors represent two sides of a parallelogram, both in magnitude and direction. Both in magnitude and direction. Suppose I want to add A and B. A and B are representing two sides of a parallelogram. Here you have to understand very carefully. A and B should represent two sides of a parallelogram, making an angle theta between them. Angle theta between them. Okay. Both in magnitude and direction. These are co-initial vectors, means they are coming from common point. They have a common point. Starting point is common. Now, the resultant is represented by the diagonal. Resultant is represented by the diagonal. Then R bar is the, otherwise you can take this as C bar. C bar is the diagonal. That resultant is diagonal. That means this is very simple, and it is a common practice also. If there is, let us assume there is a body here. A person A is applying force in this direction, person B is applying force in this direction. Then in which direction that body will move? In this direction, exactly in this direction. Let us take a catapult. Assume this is a catapult. You are pulling this catapult like this. When you are releasing, what happens? That stone will go in this direction. Arrow, you take arrow, arrow also same. So, this is A bar, this is B bar. So, two forces I am applying, one is applied like this, another one is applied like this. So, in which direction the body will move? Body will move in this direction. Okay. This is the resultant when C bar is equal to A bar plus B bar. This is the definition of parallelogram. If you understand the definition carefully, then only you can derive the equation very easily. There is a derivation, we will get one formula. If two, you can write down the definition also. If two vectors, two co-initial vectors represent two sides of a parallelogram, both in magnitude and direction, then their resultant, that means their addition, then the resultant is represented by the another co-initial vector, which is the diagonal of the parallelogram. Otherwise, diagonal passing through the same point. That is the definition. That means here this C bar is the answer. When you are adding A and B, C is the answer. Now you have to derive one formula for that. You can observe here carefully. So according to mathematics, you know, in parallelogram opposite sides are equal. So this is A bar, this also A bar, this also B bar. Okay, right. Up to here it is clear. Now what I will do, this parallelogram, I will do some construction. You drop, let us take this is O, this is P, this is Q, this is R. Okay. Now I will drop a perpendicular from Q. I drop a perpendicular from Q to meet extended OP at S. I drop a perpendicular. So this should be perpendicular. This angle should be 90. I will drop a perpendicular. At Q so that it meets the extended OP at S. Right? Okay. These two are two parallel lines cut by the same line segment. So if this is theta, this also should be theta. Okay. So mathematics knowledge is required to understand physics. Okay. This is the condition. Next what you will do? This is the construction what you are doing. Afterwards, what we will do? We will take a triangle. Within 2 steps you will get the answer. If you see your textbook, it is longer, but within 2 steps with using mathematics you can get the derivation for this. First you consider 2 triangles here. First you take triangle O, S and Q. Triangle O, S, Q. Right? Triangle O, S, Q. In textbook you might have taken A, B, C, D. You can write your name also for this, no problem. O you write your name, S you write your friend name, no problem. The thing is, The logic behind that is important. You take OSQ, a triangle, it is a triangle. Now in this triangle, what I can write is, in triangle OSQ, I can write this is a right angle triangle, so hypotenuse square is equal to side square plus side square. OS square, sorry, OQ square, OQ is the hypotenuse, OQ square is equal to QS square. This is a triangle. In this, hypotenuse square is equal to side square plus side square. QS square plus QS square plus OS square, right? Up to here accepted. Okay, this is right. Now next, this you take it as one equation, equation 1. Next, take the triangle which you constructed, which we constructed the triangle QSP, QSP. In triangle QSP, you write sin theta. In this triangle, you write sin theta. Sin theta is equal to opposite side by hypotenuse. So sin theta you can write. Sin theta is equal to opposite side QS by PQ. QS by PQ. This is sin theta, right? Similarly, write cos theta. Cos theta is equal to PS by PQ. PS by PQ. Now this you understand here carefully. Here this is a very important step. I can write QS is equal to PQ sin theta. That PQ is nothing but B. So I am writing QS is equal to B sin theta. Done. Similarly, I can write PS is equal to B cos theta. Right? Completed. Now come to equation 1. We have completed the derivation now only. Within one step we will complete. Now very simple. In place of QS you write B sin theta. So OQ square is equal to B sin theta whole square plus, you can observe this, OS consists of OP plus PS. OS is equal to OP plus PS. So this you write it as OP plus PS. OP plus PS whole square. Now this is OQ square, this is B square sin square theta plus, what is OP? OP is nothing but A bar, A. Magnitude of A bar is A plus PS. What you can write? PS is equal to B cos theta. Whole square. Now just this OQ is nothing but diagonal. I took it as C. So C square is equal to B square sin square theta plus, this is in the form of A plus B whole square. So this is A square plus 2AB cos theta plus B square cos square theta. Now B square sin square theta plus B square cos square theta is B square plus A square plus 2AB cos theta, or this you can remember it as C is equal to root of A square plus B square plus 2AB cos theta. So the formula for magnitude is, this is the magnitude. Suppose if A is 2, B is 3, angle between them is 90, you can find it. So this is the magnitude of the vector. So we are getting one formula how to add two vectors. Now what is the direction? In which direction it is oriented? Let us take C bar makes an angle alpha with A bar. Tan alpha from the, in this triangle, tan alpha, what you can write? Tan alpha is equal to, same in this triangle only, you can write tan alpha is equal to QS by Qs by Os. So tan alpha is equal to Qs by Os. Os means OP plus Os, that is equal to Qs by OP plus PS. Now this again, Qs I can write it as B sin theta divided by OP is A, B sin theta plus A plus B cos theta. Okay. This is the direction. So when you are adding two vectors, this is the magnitude, this will be the direction. So this is what you have to remember. So in some books they will take instead of adding A bar plus B bar, they will add P bar and Q bar. So whatever may be the thing, this is the definition, this is the derivation. Okay. This is what you have to remember for PUC per competitive point. If you remember the formula, that is enough. Okay. Thank you everyone for joining me.